Have you ever wondered how packaging boxes are created and transported between businesses, or how they make their way from companies to the hands of consumers? How do we get those cardboard boxes we see around our homes, in warehouses, or stores? Today, Group 6 is excited to take you on a journey to Namning Packaging Factory. Together, we'll explore how these packaging boxes are made and uncover the fascinating process behind their production, and how it leverages IRR, internal rate of return, and ROI, return on investment, to optimize operations, enhance profitability, and stay competitive in the dynamic packaging industry. All will be revealed in this video. Before diving into the business overview, let's take a moment to explore how our group decided to visit Namning Packaging Joy Stock Company. During our research, we were torn between two options, Heineken Vietnam and Napa Co. To make the best decision, we evaluated both companies using the criteria shown in this slide. After thorough consideration and calculations based on the decision-making matters, our group concluded that Napa Co would be the ideal choice for our visit. Known as Napa Co, was established in 2007. The company operates 3 production plants with a total workforce of 200 employees across its branches. At the Namning facility, there are 83 direct production workers who handle machinery and manage daily operations, supported by 16 indirect staff members responsible for management, accounting, and technical supervision. Napaco specializes in producing 3-layer, 5-layer, and 7-layer packaging, along with 2-layer corrugated paper and kraft paper. The company also provides packaging solutions featuring various corrugation types such as A, B, C, E, and F waves. Capital investment in technology and infrastructure has been pivotal to the company's success. This includes a 10,000 square meters factory equipped with state-of-the-art machinery. The production process is highly streamlined. Raw materials undergo corrugation, followed by printing, shaping, and assembly through stapling or gluing. Once an order is received from the sales department, the production team prepares a list of raw materials needed for the next steps in the manufacturing process. The primary raw material is paper rolls, which are sourced from various locations, including Vichy. For high-grade paper, the company imports from Nissan Thanh Additionally, fuel is required to support the production process. Previously, coal was used, but due to environmental concerns, the company has transitioned to using compressed wood fuel. Other materials, such as adhesive and staples, are also utilized in subsequent production stages. The raw materials are first fed into the corrugation machine in Workshop 1. The corrugation line, which is 65 meters long, requires 15 operators to manage its operation. Once the corrugation process is complete, the materials are transferred to Workshop 2 for the subsequent stages, which include printing, handled by 5 machines capable of printing up to 4 colors. Shaping and cutting, managed by 3 machines that handle base cutting and product shaping. Assembly, including stapling or gluing, supported by 2 dedicated machines. In addition to these, a continuous printing machine over 30 meters long streamlines the process, accommodating for printing units and enhancing overall production efficiency. The continuous machine operates at an average speed of 50 to 60 products per minute and is typically used for orders of at least 10,000 boxes with identical dimensions. This setup enables the production of 21,000 to 22,000 products per day, ensuring both efficiency and high output quality. Once the finished products are completed, they are moved to the warehouse for storage. Any waste materials such as paper scraps trimmed from the boards are compressed and sent to processing machines. These materials are then returned to paper production facilities for recycling, contributing to environmental sustainability. After warehousing processes are completed, the orders are loaded onto trucks and transported to customers. All of these processes are systematized using a standard operating procedure, SOP, as shown in the accompanying diagram. The SOP outlines each stage, starting from receiving the sales order to completing and shipping the final products to customers. Each phase is annotated with corresponding production costs to ensure efficient resource allocation. However, there are 3 critical stages in the process that pose potential hazards to workers. Firstly, it is corrugation machine operation. The corrugation machine is large and operates continuously, posing a risk of entanglement for workers if safety protocols are not strictly followed. The second one is shaping and cutting. This stage involves sharp machinery and occasional exposure to chemicals, increasing the potential for accidents. And finally, it is stapling and gluing. Similar to shaping, this stage involves sharp tools and adhesive substances that may be hazardous without proper precaution. To mitigate these risks, it is essential for the manufacturing unit to equip workers with adequate personal protective equipment (PPE) and provide thorough training on machine operation and workplace safety protocols. By doing so, the company ensures a safer working environment while maintaining high production standards. After interviewing and discussing with the company, our team identified the key challenge in production, product design, and quality issues caused by outdated machinery, resulting in an annual loss of approximately 8 billion Vietnam dong. To analyze this, we utilized the cause and effect fishbone diagram, which revealed 6 main factors above. We proposed a new standard operating procedure (SOP) to address these challenges. The revised SOP, as shown in the accompanying diagram, eliminates or replaces hazardous stages with safer, continuous machinery while integrating advanced technology to optimize production processes. For example, the corrugation machine has been upgraded to minimize worker exposure to risk, and shaping, cutting, stapling, and gluing stages now employ streamlined equipment to enhance safety and efficiency. With the new SOP, the production process for 45,000 products achieves significant benefits, including a cost saving of 80 million and 200,000 Vietnam dong, a 20% reduction in production time, a 33% decrease in the need for rigorous quality checks, and an 80% reduction in workplace accidents. Looking at the key financial indicators of this project, first, we have an annual growth rate of 15%, which demonstrates steady development potential in the future. With an initial investment of 1.92 billion Vietnam dong, we achieved an ROI of 135%, meaning we fully recover the investment and generate a return of 1.35 times within 3 years. The project's IRR is 34.1%, a remarkably high figure that exceeds typical discount rates, ensuring significant profitability. Lastly, the NPV with a 10% discount rate is 410 million Vietnam dong, indicating that the project adds substantial value over the 3-year period. In summary, all these financial indicators confirm that it is a worthwhile invest with a rapid payback period of just 3 years. Now, let's move on to the operational and customer satisfaction benefits of this project. First, we achieved a total cost reduction of 900 million Vietnam dong over 3 years by optimizing material and operational expenses. In terms of productivity, we observed an impressive 115% growth driven by increased output and reduced downtime. Another key highlight is a significant improvement in customer satisfaction, reaching 120% thanks to on-time deliveries and higher quality standards. This not only strengthens relationships with existing customers, but also opens up new business opportunities. Finally, we save 180 million Vietnam dong by reducing inventory holding cost, which showcases improved efficiency in inventory management. Additionally, the company uses KPIs and reporting systems to track quality performance metrics like defect rates, rework rates, and returns, with insights used to identify root causes of quality issues and optimizing processes for continuous improvement. The chart shows inventory turnover rates over time, peaking at 3 times per month initially and then stabilizing near 1 time per month. Lower turnover rates in the middle months may indicate overstocking or slower material usage. To align with the KPI target of monthly turnover, inventory management practices should focus on optimizing material flow and reducing delays in production consumption. The chart highlights defect rates across processes: assembly, finishing, inspection, and packaging. Peaks in April and October, particularly in finishing with 8% and inspection with 6%, suggest process-specific issues during these months. Assembly and packaging remained relatively stable, indicating effective controls. To reduce the high defect rates in finishing and inspection, the company should focus on equipment calibration, operator training, and stricter quality checks during those stages. Consistent monitoring can help maintain defect rates within acceptable limits. We also had the chance to experience the factory's lunch provided to employees. This meal gave us a taste of the company's efforts to ensure proper rest and nourishment for their workers and also offered us a memorable experience. In conclusion, Nam Ning's story is a testament to how strategic investments in IRR and ROI-driven initiatives can turn challenges into growth opportunities and improve competitiveness. Thank you for your attention.